can you talk to me about the design processes that you follow? Um, you did already talk a little bit about the methodologies, but is there anything else that you wanted to add when it comes to the design process? And I know we're at the very early stages, so I get that we have to get through this testing phase first in order to move on to the design phase. So where do you kind of see that going?
I've seen this routine now several times in my career, and it has started the same pattern, I guess, with this work that we're doing together. It really starts with analyzing requirements and acquiring requirements on what are you really trying to solve or what are you really trying to study. Then Dr. Pantoya and I did some brainstorming with some of our students to determine what variables we could isolate and how we might do that, like what's reasonable to build in this period of performance and the scope of this project. um, and then maybe we were poking, you always then give a chance for your teammates to poke at the big problems of the concepts and point out either the critical task or the critical failures that would make or break this success of this project. And then I think where we're going next, so I think we've done all that right now to this point. Where we're going next is fleshing out real designs and going into a build phase so that we can make this apparatus, make this diagnostic all marry together and start getting the data out. And that's pretty common. Where I think it keeps going after that is once the data is coming, um, you always find out more things and you keep growing the complexity of the system. Maybe it gets larger in scale, maybe it gets more variables simultaneously, whatever, and you keep taking data until, for me, I'm a little bit, like she said, more mature on the TRL standard than Texas Tech, but I'm still not at the final operator, right? I'm not the DoD user. So eventually you get it into a tested product. And Element does do that part also, that once it gets incorporated into a full scale system, we do that kind of testing as well, in a different regime. Like now you're testing the mill standards and you're testing to safety controls, insensitive munition things. There's all kinds of criteria once it gets to the soldier level.
As far as design goes, I really do lean on John and his expertise for the field, because if we're trying to simulate it, scale it back to a fundamental level, but simulate it, this is where John and Element come in great handy for us, because they have more insight, right? Because it's all that background that informs the design, and they know that very, very well. So, I mean, I thought John's explanation was right on the mark and fantastic, and I can't add anything to that.
Fantastic. So what would you guys say are the most significant engineering challenges that typically are faced during the design phase of a project like this, and how do you address them?
It's the things you don't consider, like you start simple and you think you're capturing an effect, and then you realize that there's an inconsistency somewhere, which it's usually the case, and you didn't consider this one thing, even though you thought through it all. And then you have to go back and you kind of have to redo it. And that's the process, right? It's a process. You don't ever do it right the first time, but you learn something, you have to redo it. You have to replan. You have to redecide a test matrix that's more accurate. It's the iteration. It's the constant optimization of just the design before you even get to the prototype. So I think the biggest challenge is which is also the most fun, because that's why it's research, right? If it was just search, we'd find it, but we have to research it, keep researching it. So I think it's really just the iteration. The challenge is can we reduce the number of iterations to accurately design a prototype, or did we kind of miss something so much so that the iteration process becomes arduous?
I agree with that is, it's the time to convergence, because a lot of time you don't have unlimited budget, or your sponsor is, even if you did have unlimited budget, your sponsor has a timeline to prove it out. And so you want to converge on that solution and do your recycling and going back as fast as possible to not lose interest from your sponsors.
So when you're talking about the prototyping, how do you typically do your prototype? Is that where maybe additive manufacturing would come in, or do you? I'm just curious. And then about how far off do you guys feel you are from a prototype? And then once you have the prototype, how far off into actual production after
So
that?
when we're describing prototype on this project, it's really an experimental setup or an experimental procedure. And to keep it as fail-safe as possible, we really are sticking to tried and true manufacturing methods. Like, use a lot of times in defense related projects, fixtures are disposable. They're getting burned, they're getting melted, they're getting explosively destroyed. So making them cheap and replaceable is part of the design consideration that I always implement, is what kind of components can we combine that have simple geometries or um, easily fabricated geometries, so that we can replace that component and get right back to the initial conditions of our first experiment. That's a critical thing. If the experimental fixture is slowly deteriorating over time, then your results are deteriorating usually as well. So we're trying to maintain those variables, and it usually is just standard machining techniques, or one element of this project that we have in the design right now is a burst disc, and it actually is a burst disc that will have temperature applied to it. So that's now more than just a pressure application, it's temperature and pressure, and having reliability on that function or that device is a new requirement that we're going to apply to a manufacturer. We're not going to make that, we're going to get it from a manufacturer, but try to hold them tight and hold them consistent in their field.
And an academic lab, additive manufacturing is a part of almost every experiment, right? Because we often can't get off the shelf components that fit our apparatus. So we just design them and print them in the machine shop downstairs, or, we've got a few printers in our lab. It's almost like a standard component of probably, I don't want to say every lab, but it's anybody working with their hands and doing experiments needs that extra mount or that extra holder. And it's things like that you sometimes you just can't even buy. And as mechanical engineers, they know very well how to design very quickly. And then now with additive manufacturing, it makes things a lot faster, more inexpensive, more tailored and personable. I actually think it helps the experimental design, this experimental process 100%.
It does go faster, that's for sure. Like, you could make an iteration on that widget 5 times in a week rather than old days.